There is a machine, launched in 1977, running on a battery the size of a microwave oven, currently somewhere around 170 astronomical units from Earth. And it is still talking to us. And before it left, we put a record on it. Not for us, for whoever might find it after we're gone. The whole thing starts with a summer student and an absurd piece of luck. The year is 1964. A young graduate student named Gary Flandreau is at JPL, tasked with the unglamorous job of plotting routes to the outer planets. And while most people would have seen a spreadsheet problem, Flandreau spotted something extraordinary. Once every approximately 175 years, Jupiter, Saturn, Uranus, and Neptune line up in a rare gravitational curve. If you launch the right spacecraft at exactly the right moment, it could swing from one giant planet to the next, using each one as a cosmic slingshot, visiting all four on a single mission without needing nearly enough fuel to do it the hard way. No extra rockets, no refueling, just gravity, patience, and very good timing. Flandreau calculated that the window was opening in 1977, not sometime around the 1970s. 1977. Miss it, and you'd be waiting until roughly 2153. NASA said yes. Well, first they said yes to a big version, for Spacecraft, a full grand tour. Then Congress saw the budget and said no. NASA came back with 2 spacecraft and a new name, Voyager. March 7th, 1977. 2 probes, 1 shot at the alignment. Now here's the thing that breaks your brain a little. The probes were named before anyone knew which one would fly first. Voyager 2 launched on August 20th, 1977. First, Voyager 1 launched 16 days later, on September 5th, 1977. Second, why is it called Voyager 1 if it launched second? Because it was aimed at a faster trajectory. It overtook Voyager 2 on December 15th, 1977, about 3 months in, and from that point on, it was never behind again. One footnote: on Voyager 1's launch, the rocket's second stage cut out early. The Centaur upper stage had just 3.4 seconds of propellant left when it reached the right velocity. The probe that became the most distant object in human history nearly didn't make it off the ground. Both probes are using gravity assists. Sounds like a shortcut, but it's real physics. Here's how it works. A planet isn't sitting still, it's barreling through space on its own orbit around the sun. When your spacecraft flies close, the planet's gravity curves your path. From the planet's point of view, you swung around and left at the same speed you arrived. But from the sun's point of view, the planet lent you a fraction of its orbital momentum. You leave faster than you came. Each giant planet added velocity. By the time Voyager 1 was done with Saturn, it was moving fast enough that nothing, no planet, no orbit, no amount of solar gravity, could pull it back. Voyager 1 hit Jupiter in March 1979 and Saturn in November 1980. At Saturn, engineers made a deliberate choice. Swing the probe close to Titan, Saturn's biggest moon. That flyby bent Voyager 1's path northward, up and out of the plane of the solar system, which meant no more planet encounters. That was the trade-off. Voyager 1 got Titan. It gave up everything else. Worth it, probably. Titan had a dense nitrogen atmosphere, thick with organic haze, hiding its surface entirely. Nobody expected that, but Jupiter had already given us the real jaw drop. On March 9th, 1979, navigation engineer Linda Morabito was running long exposure images to pin down the spacecraft's exact position. Doing math, basically. Then she noticed a 270-kilometer tall plume erupting off the limb of one of Jupiter's moons. It was a volcanic eruption, on Io. the first active volcanoes ever found anywhere other than Earth. When scientists went back through the earlier images, they found 8 volcanic plumes erupting simultaneously. Io wasn't a dead rock. It was the most geologically violent body we'd ever seen. Voyager 2, meanwhile, kept going. Saturn, in 1981, then, in January 1986, it became the only spacecraft in history to reach Uranus, discovering 11 new moons, 2 new rings, and a magnetic field tilted so far off, Axis scientists are still arguing about why. And then Neptune, August 1989, 4,800 kilometers above the cloud tops, finding winds exceeding 2,100 kilometers per hour, the fastest in the solar system, and a moon called Triton with active nitrogen geysers erupting from the coldest surface any Voyager had ever measured. No other spacecraft has been to either of them since. Those Voyager 2 images are still the only close-up views of Uranus and Neptune that exist. Before all of that, before the launch, before anyone knew what the probes would find, someone asked a question that had nothing to do with science. If these things are going to leave the solar system and wander through interstellar space for billions of years, shouldn't we put something on them? NASA handed the job to a committee chaired by Carl Sagan at Cornell and gave them approximately 6 weeks to decide what the entire human race should say to the universe. Creative director Anne Druyan, technical director Frank Drake, designer John Lomberg, a small team, an impossible brief, and a ticking clock. The result is a 12-inch copper disc plated with gold, a record, a literal vinyl record, with a stylus included, containing 115 images, greetings in 55 languages ranging from ancient Akkadian to modern Wu Chinese, and roughly 90 minutes of music. Bach, Beethoven, Chuck Berry's Johnny B. Good, Indonesian gamelan, Peruvian panpipes, the Beatles, well, not the Beatles, actually, copyright issues. Even the message to the cosmos has a rider. There are natural sounds: surf, wind, thunder, birds, whales. There's Anne Druyan's own brainwave recording. There's an inscription hand-etched on the record's surface that reads, "To the makers of music, all worlds, all times." On the aluminum jacket, a pulsar map, so any recipient can trace the record's origin back to our sun. A drawing of the hydrogen atom as a universal time and frequency reference. A kind of cosmic Rosetta Stone for the instructions. And electroplated onto the cover, a tiny sample of uranium-238. Half-life, 4.468 billion years. A radioactive clock, so whoever finds it can calculate exactly how long it's been drifting. We built a message designed to outlast our civilization. We put it on 2 probes aimed at the stars and flung them into the dark. And then 10 years later, Carl Sagan asked one more favor. On February 14th, 1990, Voyager 1 turned its camera back toward home for the last time. It was 6 billion kilometers away. Earth, in the final frame, is less than a single pixel. A pale blue dot, half lost in scattered sunlight. Sagan had lobbied NASA for years to take this photograph. It had no scientific value, they told him. He lobbied anyway. That's here, that's home, that's us. He wrote that the image should remind us of our responsibility to preserve and cherish the pale blue dot, the only home we've ever known. 34 minutes after the photograph was taken, the cameras were turned off. Voyager 1 would never look back again. Both probes are still out there. Voyager 1 crossed the heliopause on August 25th, 2012, the boundary where the sun's solar wind gives way to true interstellar medium, at about 122 astronomical units from Earth. It became the first human-made object to enter interstellar space. We didn't actually know until September 2013. Voyager 1's plasma instrument had stopped working in 1980, so confirmation required indirect evidence. A solar outburst that triggered plasma oscillations scientists could measure from the signal. An 80-fold jump in electron density. That was the proof. Voyager 2 crossed on November 5th, 2018, at about 119 astronomical units. Unlike Voyager 1, its plasma instrument was still working, so the crossing was confirmed in real time. 5 peer-reviewed papers followed, the most complete direct measurement of the heliopause ever recorded. As of mid-2026, Voyager 1 is around 170 astronomical units from the Sun, roughly 25 billion kilometers. Voyager 2 is about 142 astronomical units out, heading south of the ecliptic plane. They are both, by a very wide margin, the most distant objects ever made by human hands. The power is dying. Each probe runs on 3 plutonium RTGs, losing about 4 watts of output per year since 1977. Engineers have been shutting down instruments, one by one, to extend the mission. With careful management, at least one science instrument on each probe may survive into the 2030s. After that, silence. Here's what strikes me. We built 2 probes on a budget in the 1970s, sent them on a route that only opens once every 175 years, and they rewrote what we know about 4 planets, dozens of moons, and the edge of our solar system. Still doing science 49 years later, carrying a record built to last billions of years. Somewhere out in interstellar space right now, 2 gold-plated discs are carrying Chuck Berry and whale songs, and the brainwaves of a person who loved the cosmos. Headed for nothing in particular. No destination, no return address. Just a message, in case someone's listening. If that kind of story is your thing, and if you're still here, it clearly is, hit subscribe. Every week, another moment where humans looked up, asked a ridiculous question, and somehow answered it. We'd love to have you along. Next time, the telescope that nearly ended NASA's reputation, and how a team of astronauts with wrenches fixed it in orbit and changed how we see the entire universe.